In the last lesson, we talked about the Richter scale and how it measured earthquake magnitude. Today, we're talking about the Mercalli scale, and we'll also touch on the moment magnitude scale, but mainly we're talking about the Mercalli scale. It doesn't measure magnitude, it measures intensity. So the Mercalli scale is a scale that measures earthquake intensity. Intensity is just the amount of damage done by the earthquake. The intensity is determined by observation and comparing to a scale. So this is a pretty simple scale compared to the Richter scale. So let me just jump ahead a little bit and we can see how we're observing and comparing to a scale. So here is modified Mercalli intensity scale. So we observe the earthquake. And let's say that my windows cracked and I was woken up and all this horrible stuff happened to me. Well, all we do is we look at the number here and we find out what it would be. Let's say that, oh, it was a 10. Okay, these things happened. So it was a 10 on the intensity scale. Okay, so we're just going to observe what happened and then compare what we observed to this scale. So it's really a pretty simple one. So we're going to observe and compare it to a scale. What are some factors that are going to affect the intensity of an earthquake? There are lots of them. We're just going to go over some of the main ones. The magnitude of the earthquake. That's a pretty obvious one, right? If it's a high magnitude earthquake, there's a good chance that it's going to be some high intensities for that earthquake. If it's a small magnitude earthquake, probably not very intense. The depth of the earthquake. That matters a lot. Shallow earthquakes usually cause more damage, so more intensity. Deeper earthquakes cause less damage, lower intensity. Deep earthquakes cause less damage because the waves kind of die down by the time they get to the surface where all the buildings are. The shallow earthquakes, the waves are really strong still when they get to the surface and destroy everything. Distance from the epicenter, again, a pretty obvious one. If you are really close to the epicenter, there's a good chance it's going to be a higher intensity. Geologic conditions, we talked a little bit about this already, but if you're on really hard ground, it's probably not going to be as intense as if you were on really soft or loose soil. Structural integrity of buildings, again, that makes sense. If you are in badly built buildings, it's going to read a higher intensity because worse things are going to have happened during that earthquake. So in general, the stronger the earthquake is and the closer you are to the epicenter, the higher the intensity will be. This scale really pretty much makes sense. You see what damage was done. Oh, that was the intensity. Again, we already looked at this. You don't have to memorize this. You're going to be using the intensity scale for an activity for tonight's homework or tomorrow's homework. And I'll show you that activity kind of at the end of this. Okay, a couple of characteristics of the Mercalli scale. It is older than the Richter scale. It was developed by an Italian, Giuseppe Mercalli, in 1902, and then modified by Americans Wood and Newman for modern conditions in 1931. It goes from 1 to 12. You can see it's in Roman numerals. Okay. It is a very subjective scale. So what that means is it's based on opinions and observations instead of scientific measurement. Subjective is the opposite of objective. Okay, there's no necessarily one correct answer for this. There may be lots of intensities, lots of possible answers. And kind of comes to the next one here. While an earthquake has only one magnitude, it can have many intensities. When we had earthquakes before, we were talking about, oh, it was an 8.9 magnitude. That was it, 8.9. There weren't other magnitudes. With Mercalli scale, it could have lots of intensities. So how or why is the Mercalli scale useful? Well, first of all, it's easy to find. They used to do mailings with postcards and calls. Now they do a lot of it on the internet. And let me show you how this works. So you just go to this website, Did You Feel It? And when it gets there, it's going to show you some different earthquakes that you might have felt. The most intense one was this one here, so let's go to this one. Oh, it was actually in northern Texas. So we go to it, you see kind of the intensity ratings down here already, going 1, not felt, not very intense, going all the way up to a greater than 10, okay, the really horrible ones. And you can see the different colors here a little bit. So let's go up here, it says, did you feel it? Sure I did. Let's put in the zip code for the school, 75229. Hit continue. So what we're gonna do, so did I feel it? Sure I did. My physical situation, I was, let's say, inside a building. My building was a mobile home. I woke up. Did others feel it? Yeah, most felt it. Earthquake effects. The free-hanging objects were violently swinging, and the sounds were loud, and the shells objects, nearly everything fell off, and the large appliances, yes, they were all overturned. And you just basically click all these different things. How did I react? I was extremely frightened. And you can say, and I'll check all these little things too. And so you do that, and you check all these little boxes, you hopefully answer truthfully. And when you do, you hit submit report. We're not going to, okay? I don't want to get in trouble for submitting a false report. But when you do submit it, you are going to get an ISO, or it's gonna give you an intensity, and it will make an isoseismal map like this. And we're gonna look at one in our PowerPoint coming up. But it's very easy to find these. Basically, just go to the internet and you type in what you saw and felt, and it will figure out what intensity number it was for you. How is it useful? Well, we use it for building codes and city planning with architects and engineers. I'm going to show you that on the next map um, coming up. It's also very good for insurance rates and insurance fraud. Again, we'll see that on this map coming up. What are some problems with it? Well, the first thing is it is subjective. Everybody is going to see something a little bit differently. Good example of this. Let's say that you go out to California and for college, and it's your first time ever being in California, first time ever experiencing an earthquake. So there's an earthquake, and you were woken up and you were extremely frightened, like it said there, and you thought the world was going to end. It was just the most terrifying experience you ever had. And you run out, and the news people are there, and they're interviewing you, and you tell them how horrible it was. And it was frightening, and it was, oh my God, it was like a 10 intensity. And then your neighbor comes out, and he's lived in California for 20 years or 30 years, and he's like, yeah, woke me up, but just a little earthquake. I went right back to sleep. Okay? He didn't feel as scared as you. He didn't see all the stuff that you saw. So his rating might be like a 4. Well, you said it was a 10. So it is very subjective. You need to have human observation, obviously. If there isn't somebody there to observe it, you're not going to get the intensity. You can also have liars. Maybe people can lie on these forms. Or again, think if they're interviewing you for the news. Are you going to go onto the news and say, no, it wasn't very bad, I slept right through it? No, if the news people come, lots of times people exaggerate. Oh my God, it was horrible, and my dog ran away, and I was scared. Oh my God, it was horrible. Okay, lots of time you might have liars. So there are definitely some problems with the scale. But let's go back and talk about this usefulness and how it's good. And what we're going to do is we're going to look at a map of the isoseismal map, so the Mercalli Scale intensity map for the Northridge earthquake. So this was that huge earthquake in Los Angeles in 1994. The epicenter is the star here. You can see it was centered around Northridge. Down here is Malibu. Here's Los Angeles. And you see the intensity ratings going from 1 not felt all the way up to the 10 plus, okay, the major destruction zones. And you look at this and you really can figure out or see how it's useful. Some of the things to look at. Places that were destroyed near other places that weren't destroyed. You have some areas down here that are reds. Why are they destroyed? Maybe architects and engineers are going to look at those areas. Good example like here. Tons of extreme destruction here. Were these all built by the same architect, all these buildings? Okay, the same engineer. So maybe architects and engineers are going to go to this area and look at them and figure out what went wrong with these buildings and learn for the future. Or maybe the geologists go here and they look at the soil conditions. Maybe it was really loose soil here. It's a good example for here maybe, right on the coast. Maybe it's really waterlogged or loose soil here. So they can look for that. Insurance rates, insurance fraud. If you're in one of these red areas, what do you think your insurance is going to do next time you have to renew? Well, it's going to go way up because you're in an area that could experience, very bad damage. Also fraud. If you are in an area that wasn't hit very well, hard, let's say maybe this little area in here, you look around on the news and everything's destroyed but your house wasn't destroyed. But you claim that you need a new chimney and you need a new roof and your windows are broken. You make all these horrible claims. But they look at it and they look at this map and they say, well, your house shouldn't have been destroyed that badly. You weren't in the area that was destroyed. And they can come look at you for insurance fraud. So very, very useful. City planners, places to put fire stations, police stations. You might not want to locate a fire or police station in the red areas. Maybe you want to locate them in like here's a blue area, but that's close to maybe a red area. So after another earthquake, if the same areas are hit, you can easily get in and provide help, but your fire station is destroyed. So city planners use these a lot. I said architects, engineers, geologists, insurance companies. The Mercalli scale is very useful for lots of different things. So it's a great scale. Some people think it's a lot more useful than the Richter scale because it is just very real life. It's what people saw, it's what people felt, and you can use it for city planning, architects, engineers, and all that kind of stuff. What you're going to be doing for homework is you are actually going to be making a map that looks similar to this. So let me show you what that is. This activity is based off of a real earthquake that happened in California in 1971. You're all going to get a map like this of Wattsville, and then you're going to get a sheet of about 26 or 27 or so different people that called into a radio station, and they describe what they experienced. For example, caller number 1 said, "Hi, this is Charles from the hospital. Everyone ran outdoors and we only had moderate damage thanks to a well-built building." What you're going to do is you're going to read these descriptions, look at the intensity scale, and then find the location where he is and put on the number. So we can do this first one together. Let me get my pen. And I'll do whatever. Fine. So what do you think this intensity is? Everyone ran outdoors, moderate damage thanks to a well-built building. Look down here, let's see. Felt by everybody, heavy furniture moved, fallen plaster, yeah. 7, everyone frightened, overturned furniture. I don't know, maybe it's a 7. I'm going to say a 7. But again, you see how it might be subjective. Some people might say 6, some people might say a 5 only. Maybe some people say 9. Yeah, it's whatever you decide. I'm going to say it's a 7. He was at the hospital. So the hospital's right here, it says. So that should be a 5, 6, 7. Okay, again, Roman numerals. If you want to do it in Arabic numerals, that's fine. Okay, so if you don't want to write in Roman numerals. So it's a 7. Then you can read caller number 2, and he is somewhere else, and caller number 3 somewhere else. And you're going to get more of these things. Let's say there's another 7 over here. Let's say there's an 8 right here. Maybe a 6 here, and a 6 here, and let's say a 5 here, and a 5 here. Whatever you find. So you're going to plot all these 20-some different experiences on this map. And when you do, hopefully you're going to find some patterns. And what you're going to do is then color. So let me bring up some colors to show you kind of what you're going to do. Let's use highlighters actually. So let's say you're going to give yourself a key. Let's say yellow is going to represent 6, intensity of 6. And I look and I'm like, okay, intensity of 6 is kind of like this. Whoop, it needs to go up here. Okay, so 6s are like this. So I'm going to color all this in and say that is my intensity 6 for my isoseismal map. And then you'll get a different color. Let's see if I can find another color. Red. I'm going to say red is my 8. My 8s are right in here. And I get a different color. And I'm going to say this color is my 7s. And the 7s are all here. Okay, so what you're doing is you're making an isoseismal map just like this, but for Wattsville. Okay, so that's going to be your homework. You're going to have, I don't know, 6 or 7 different colors on your map. Okay, just like I said, just making this, but making it for Wattsville. That's going to be your homework tonight. I'll give you all these sheets and I'll give you all the color descriptions. Last thing before we go though, I just wanted to mention the moment magnitude scale because it is kind of one of the newer scales and it's being used a lot more than the Richter scale now. So it's a rating system that estimates the total energy released by an earthquake. Usually it is reported as a Richter scale measurement. Okay, so it kind of is confusing because they'll say it as a Richter scale magnitude when really it wasn't the Richter scale, it was the moment magnitude. doesn't really matter a whole lot. Seismologists study seismograms to determine what kind of waves were produced by the earthquake and how strong they were. That allows them to infer how much movement occurred along the fault and the strength of the rocks that broke when the fault slipped. It works better than the Richter scale for large earthquakes and far away earthquakes. So it's very similar. We're using the seismograms and we're looking at the amplitude and time lag and we're figuring out how much the ground moved and what the energy was with it. So very similar to the Richter scale. So when you're doing your projects, you might see different things. You might see like an MW, that's hard to say, but an MW or an I don't know what another one is, M something else. And a lot of those are just referring to different scales. Might not be a Richter scale, it might be a moment magnitude scale also. And that's it for the different types of scales that we're going to be talking about.